Karma Logistics, a software as a service provider, is happy to introduce a weekly slotting service. We slot, you save. By keeping your product slotting for optimal picking, we can add another 8 to 12% increase in your picking productivity. This will also indirectly improve your put away and stocking productivity as this video will explain some of the basics in reslotting. We have included an actual case study also in this video. Let us first show you a few past applications. This layout represents a finished goods warehouse attached to a manufacturing facility. A layout with every type of storage. This warehouse contains electrical parts. This is an air filter and oil filter distribution center, a hospital and nursing home products distributor, over 50 facilities in the U.S. The color codes represent product velocity codes. The arrows show the product move suggestions. A major hair care and cosmetic distributor has a mezzanine bin picking in the first level. Food products manufacturer and distributor with 4 large facilities in the U.S. Why do we need a review of the product slotting? In the pictures shown here, we are picking a total of 6 items in both drawings. In the picture on the right, we will incur less travel time. We all know that travel times constitute 60% or more of the total picking time. By improving the product slotting, we can attempt to reduce this large travel component of the total picking time. To illustrate the complexity involved in slotting for optimal efficiency, let us take the Rubik's Cube. We have all attempted to do that puzzle. The cube in the picture is the basic 3x3 Rubik's Cube. Wow, do we even want to solve a 9x9 Rubik's Cube? I certainly don't want to. I got this from Google Image. It is called a Rubik's Cube as wallpaper. Let us just leave it at that. This must be another Rubik's Cube wallpaper. No, it is part of a facility layout with product velocity code shown as a color code superimposed on the current layout. Every DC has a daily puzzle to find the best way to slot their products. If you don't solve each day's puzzle that day itself, within a month you will have over 50% of the items slotted in the wrong places. Plus, no way to make changes because now the facility is 120% of its design storage capacity. How do we start solving this puzzle? First, we model your facility as an X, Y, Z coordinate facility. While moving all the high velocity items to premium pick slots, we should remember not to create congestion by putting all the fast moving items in the same aisle. Can we consider some limited amount of batch picking, say in the C section? Otherwise, the gains made in the A and B areas will be lost in the C area. Do you use cube and case dimensions? If you don't, you should. Using cube-based work assignments along with engineered time standards is a winning combination. If your facility does not have both cube and product dimensions, we can still suggest product moves with limited information. Of course, it will be the same as the moves obtained with cube information. It will not be the same as the moves obtained with cube information. Why do we number all of our aisles from 01, 02, 03, starting in one end and work our way to the opposite end? Old habit. This old system locks in poor productivity because every order is forced to walk across the majority of the C items. Can we start in the middle with one pick cycle going left and another cycle going to the right? Take this simple field test. Find out the SKU number and the slot number of the topmost 3 movers. Actually, walk over to those slots. You may be surprised at what you will find in terms of its location and amount of forward pick quantities offered. What or who is a quick stick? Usually in a crowded facility, the inbound put-away forklift staff will go around a few times looking for an empty pallet position. After the third round, he will place his products in the first empty slot that he comes across. This is called quick stick. It is common for many large facilities to have another smaller overflow facility. Here the main DC is full and full of slow-moving products that will not budge. All the newer and faster-moving items end up in the overflow DC. Every day's picking cycle in the main DC cannot be completed until a transfer truck begins that day's product requirements from the overflow DC. Why not just do random slotting? The answer is a maybe. You need to reserve and fix slot locations for the A and B items in the best possible positions. It is okay to consider random slotting for the slow-moving items. How about slotting items that need to be in a family? Yes, in some industries, as in grocery distributions, these products within a family need to arrive together so they can be stocked at the retail shelves accordingly. What is the connection between a good slotting and engineered time standards? Having engineered time standards is like having a thermometer to provide an accurate measurement of the productivity. What data do we need to keep the facility slotted the very best and every day? We need 3 types of data. 1. Item description details. 2. A week's worth of order pick data. 3. Current slot item inventory data. We will show examples of these in the case study. In addition to the 3 types of data, we define various placement criteria. That defines where a certain type of product may be slotted in certain ranges of slot locations. In our slotting software, the same SKU can be picked in 4 different types of slot sizes, like a bulk slot, a pallet rack slot, a carton flow bin, and a small static bin. All the slot moves are based on the highest priority items, so we will gain the most travel time savings. Often these moves are done in pairs. In order to move a top priority item to a premium slot, we may need to get rid of a slow-moving item occupying that premium slot. In the slide shown, all the slow items are highlighted in yellow color and the top movers in red color. Internally, we employ various move techniques. They are proprietary information. The top 2 types of common moves are direct move, move to an empty slot of the right kind, daisy chain, a 2-step move. When similar looking products like in the pharmaceutical industry are slotted next to each other, picking errors may occur. We use some special techniques to avoid such errors. Before we ask you to follow our recommendations, we simulate the facility before the moves and after the moves, using 1-week pick level order data, and tell you what is the difference in travel time, and we call it the penalty cost. We will now illustrate some of these concepts by showing an actual case study and the software screens. The facility is around 350,000 square feet in size. It has just about every form of storage slots. In the project, we were asked to limit our review only to the pallet rack section, shown in the red color aisles. About 3,800 SKUs in this section. Products are received on the right side. The completed orders move into a package area and then shipped via doors on the left side. One of the 3 data, product data, is given by the customer. We convert the customer's data into our internal standard format. Customer's order data. The converted internal database. Customers' on-hand inventory data, slot number, SKU, and on-hand. Our converted database. Every day, we download the 3 data files from the customer processed through our model of that facility, and we recommend the list of high-value product moves. We do it again the next day. All our simulations use the XYZ path coordinates. If you have Argent's engineered time standards, you may already have this travel path worked out. We define both speeds and capacities for forklifts. Forklift operations may have different work schedules. Include staff and work shift details. Staff may be assigned to different sections of the facility. They may have different work shifts. Insert accurate work standards for manual picks. Define both labor and space costs to compute penalty costs. Product placement groups. These groups define what types of products can be slotted in what sections of the facility. Based on the placement group criteria, we first indicate which items are occupying the wrong slots. We run the slot move routine to highlight the high-value moves. We graphically show the various slot moves. We now run the 2 simulations, before the moves and after the moves. This identifies the penalty cost associated with the suggested moves. Penalty cost. This screen shows that today's moves are worth $8,000 to the facility. By employing our slot move techniques, we have achieved